Here's something wild. While every automaker is stuffing more screens, motors, and gadgets into budget cars, Tesla just announced they're doing the exact opposite with Model 2. They're removing parts, hundreds of them, from seats to dashboard assemblies to climate controls. The automotive press is calling it cost-cutting, but is it? Or is Tesla betting on something most drivers won't realize until year 5, when repair bills start hitting? What if cutting interior parts isn't about saving money at the factory, but about stopping your car from quietly draining your wallet every month after you buy it? That's the question no one's asking. Traditional automakers spend 12 to 15 labor hours just assembling an interior. That's not building the car, that's just clicking together trim panels, running wire harnesses, installing switches, mounting speakers. Tesla is targeting 6 to 7 hours for Model 2. At typical automotive labor rates, that removes $800 to $1,200 per vehicle. But here's what matters more. That's not where the real savings happen. The real savings hit 5 to 8 years later, when you're the one paying the bills. Window switches, seat motors, climate control actuators, infotainment buttons. These are the most common interior failure points in vehicles aged 5 to 8 years, and industry service records show they account for $150 to $400 per year in out-of-warranty repairs for compact cars. Most buyers never calculate this when comparing purchase prices. Over 10 years of ownership, interior electrical repairs alone can add $1,500 to $4,000 to your total. That's a 6% to 16% hidden tax that shows up years after you've driven off the lot. Take the seats, for example. Model 3 and Model Y use multi-motor adjustable seats. Each seat system costs roughly $600 and contains 3 to 5 electric motors. Those motors fail, and repair costs run $300 to $700 per seat over a vehicle's lifetime. Model 2 is expected to use manual or limited motor seating, dropping seat costs to under $250. The immediate reaction is to call this a downgrade, but consider the use case. Budget EV buyers typically keep their cars 10 years or more, so the question becomes practical. Would you rather pay $500 to fix a lumbar motor in year 7, or just reach down and turn a knob? Tesla isn't optimizing for the showroom test drive. They're optimizing for mile 120,000. This philosophy extends to every surface you touch. A typical compact car dashboard is an assembly of 30 to 50 individual parts. Each joint is a potential squeak, each connection a potential failure. Model 2 is rumored to use a single-piece structural dash, mirroring the Giga casting approach. Fewer parts means fewer joints, fewer service visits. But there's another benefit. Weight reduction. Replacing multi-piece assemblies with molded components saves 15 to 25 pounds just from the dashboard. Add similar reductions across door panels and trim pieces, and every 100 pounds of total weight reduction improves efficiency by 1% to 2%. Over 12,000 miles per year, that's 120 to 180 kilowatt hours saved annually. At 15 cents per kilowatt hour, that's $18 to $27 staying in your pocket every year. Compound that over a decade, and you're looking at $180 to $270 in electricity costs that simply don't exist. Now the screen, because this is where perception and reality diverge. Model 3 uses a 15-inch display. Model 2 is expected to use 10 to 11 inches. That saves $200 to $300 in manufacturing. But the more significant benefit is operational power draw. Lower power draw means less strain on the 12-volt system and longer component lifespan. This is where Tesla's thinking fundamentally diverges from traditional automotive logic. A legacy manufacturer asks, what impresses customers on day one? Tesla asks, what costs customers money on day one, $1,825? The screen size matters less than the repair invoice you'll never see, and the gradual battery preservation you'll experience, but never consciously notice until you check resale values years later. Climate control is where this gets technical, but it's worth understanding. A typical compact car HVAC system uses 4 to 7 electric actuators to control airflow. Service data shows HVAC repairs average $220 to $480 per incident, with failures typically appearing between 70,000 and 110,000 miles. Supplier rumors suggest Model 2 will reduce actuators by 40% to 60%, removing 3 to 5 common failure points before they can break. But the more interesting aspect is energy consumption and battery longevity. Conventional HVAC systems pull 2.5 to 4.0 kilowatts during peak use. Tesla's current heat pumps operate at 1.5 to 2.0 kilowatts. If Model 2 has 8% to 12% less interior volume than Model 3, the sustained HVAC load drops even further. Lower HVAC load means less frequent deep battery cycling during daily driving. Over 150,000 miles, that translates into measurable battery preservation. Even a 5% difference in usable capacity can swing resale prices by $1,500 to $3,000 in the used EV market. Most buyers focus on upfront range numbers. Tesla is betting on long-term capacity retention instead. The buyer who keeps Model 2 for 12 years will have a battery pack that's aged slower than comparable EVs. That's not a feature you can demonstrate during a test drive, but it protects your investment when you eventually sell. This brings us to materials where most criticism focuses. Soft-touch plastics, stitched panels, wrapped door cards look premium when new. But interior refurbishment data tells a different story over time. Cracked dashboards, peeling trim, UV-damaged surfaces. Cosmetic repairs average $600 to $1,400 over a vehicle's lifetime, concentrated in years 6 through 10 when these materials degrade. Model 2 is expected to use single-layer molded panels, similar to commercial vehicles and fleet cars. These feel firmer to the touch, no question, but they last 12 to 15 years without surface failure, even in high-heat environments like Arizona or Texas. Here's the fundamental trade-off. Do you want an interior that feels expensive for 3 years and looks increasingly worn for the next 7? Or one that feels utilitarian from day 1 and still looks the same on year 10? For buyers focused on 3-year leases, this is a downgrade. For buyers planning to drive 150,000 miles over a decade, this is arguably an upgrade disguised as cost-cutting. Noise control represents the final piece, and it's where Tesla's approach is most unconventional. Traditional sound insulation relies on foam, felt, and rubber mats that add 25 to 40 pounds and degrade over time. Tesla's strategy appears to shift towards structural stiffness from the next-generation unibody. A stiffer body shell reduces panel flex, the primary contributor to road noise above 60 miles per hour. Tesla's already demonstrated this with Model Y's large castings, where fewer body joints correlate with lower vibration transmission. When noise is separate, generated by airflow around mirrors and door seals, there's no indication Tesla is downgrading door seals or glass thickness, which account for 70% of perceived highway noise. The result is that Tesla is trading materials that degrade over time for structural solutions that remain constant throughout the vehicle's life. So here's the real question. Who is Model 2 actually for? If you're leasing for 3 years and prioritize showroom impressions, Tesla's approach will feel like a compromise. But if you're buying to keep for a decade, you're getting a vehicle engineered to minimize the slow financial bleed. Most budget cars inflict through component failures. The average compact car owner spends $2,500 to $4,500 on interior-related repairs over 10 years. Model 2's design targets that number by removing components most likely to fail. This isn't about making a cheap car, it's about making a car that stops costing you money after you've paid for it. And here's what most analysts are missing. Tesla's designing for the used market. A 2019 Model 3 with 80,000 miles still commands strong resale prices, partly because interior components held up better than comparable vehicles. If Model 2's simplified interior proves more durable, used Model 2s 5 or 6 years from now could retain value substantially better than comparable budget EVs with complex interiors that age poorly. That's not speculation, that's pattern recognition from how Model 3 has performed versus Nissan Leaf or Chevy Bolt. Better durability directly translates to higher residual values, reducing total cost of ownership even for buyers who eventually sell. So here's what this really means. Tesla isn't cutting costs, they're cutting future repair bills. Model 2's stripped interior removes the parts that fail most often between years 5 and 10. Manual seats, single-piece dash, simplified HVAC. These aren't downgrades. They're targeted eliminations of the components that cost you $150 to $400 per year once warranty ends. That's $1,500 to $4,000 over a decade that simply doesn't exist with Model 2. And if this strategy works, every budget EV maker will have to follow. We're already seeing VW and Renault move towards simplified interiors. The industry is watching Model 2 closely because it answers a question no one else has solved. How do you make an EV affordable to buy and cheap to own? Production starts late 2025. The real test comes at 100,000 miles when traditional budget cars start breaking down. What do you think? Will buyers choose long-term durability over showroom luxury? Drop your answer in the comments. Hit the like button if this breakdown gave you a new perspective. And subscribe to Tesla Zone with notifications on so you catch every update as Model 2 moves from rumor to reality. This is how affordable EVs finally make financial sense. And it's happening now. 497 miles, 75,000 pounds, one charge. Tesla Semi just proved every diesel defender wrong with real numbers, not promises. Over 300 trucks are already running daily routes for Walmart, PepsiCo, and DHL, averaging 1.55 kilowatt hours per mile while climbing 7,200-foot mountain passes. This isn't testing anymore. Tesla's Nevada factory is targeting 50,000 units in 2026, priced at $200,000 for the long-range version. So here's what changes everything. Can the diesel industry survive when electric now matches range, beats efficiency, and cuts operating costs? Let's talk about why diesel manufacturers are suddenly panicking. For years, they dismissed Tesla Semi as vaporware. The prototype looked cool but couldn't scale, they said. The range claims were impossible, they insisted. And then Tesla did something brilliant. They went completely silent. No flashy announcements, no Musk tweets, no hype. Just thousands of miles of real-world testing that nobody was paying attention to, until now. The Tesla Semi rolling out in 2026 looks nothing like the 2017 prototype. Program manager Dan Priestley confirmed they've rebuilt nearly everything. The front end now features a horizontal LED light bar matching Cybertruck's design. The windshield shrank because less glass means less weight and better aerodynamics. The roof line got smoothed, the bumper simplified for easier repairs. These aren't cosmetic tweaks. Every modification serves one purpose: pushing that drag coefficient lower. The original Semi hit 0.36, incredible for a Class 8 truck when diesel rigs sit at 0.65 to 0.70. Gen 2 targets 0.33 or lower. Here's why that matters. Dropping drag by just 0.02 reduces energy consumption by 5 to 7%, adding dozens of miles per charge. That difference separates viable electric trucking from expensive experiments. But there's something wilder happening. Tesla tested aerodynamically optimized side panels with powered electric doors, similar to Model X. Critics immediately called it impractical for a work truck. Yet preliminary data shows genuine potential: improved airflow, obstacle detection, automatic sealing preventing air leaks. Would you trust electric doors on an 80,000-pound freight hauler, making dozens of stops daily? Or is this over-engineering? That answer might determine whether this feature survives to production. Gen 2 runs on 4,680 cells, Tesla's tabless battery architecture. The long-range version packs roughly 850 kilowatt-hours with energy consumption hitting 1.5 to 1.7 kilowatt-hours per mile. Compare that to Freightliner e-Cascadia, averaging over 2 kilowatt-hours per mile. This isn't marginal improvement. This is the difference between profitable operations and financial bleeding. The 4680